Geometry Unit Section 5 Volume. When you're concerned with things like the holding capacity of a tank, the amount of concrete needed for a driveway, foundation, entrance steps, etc., displacement of an engine, or the size of a room, the HVAC requirements, all of these are dealing with volume. Volume is the three-dimensional space occupied by an object. Volume is usually expressed in terms of cubic units, such as cubic inches, cubic yards, and so on. These measurements may be converted to gallons, fluid ounces, or liters when talking about liquid volumes. When given a three-dimensional object such as this rectangular solid, like a shoebox, volume is determined by counting the number of cubes of a given size that will fit inside that object. A cube is simply a box where each side has the same length. Here, the blue box is a 1 foot by 1 foot by 1 foot, and we're looking to see how many cubes fit in this larger space. And it turns out there were 24 cubes, resulting in a volume of 24 cubic feet. We can determine the volume of a figure two ways. One is a direct measurement. This is the method where you fill up an object with fluid, then pour the fluid into a graduated cylinder or beaker. The reading you obtain from the graduated cylinder or beaker represents the volume of the object. Here's an example of where head cylinders were calculated by filling them with fluid and then reading out the amount of fluid in the graduated cylinder. We also can calculate the volume using a basic volume formula. To find the volume, we take the area times the height. Most three-dimensional objects, like a rectangular solid or a cylinder, think of a pop can or a barrel, have what we call a face side. The requirements of this face are that this base area shape must not change from top to bottom. If you look directly opposite from this face side, you should see the same size and shape on the opposite end of your three-dimensional object. If this is true, we can continue on, provided that these two faces or bases are parallel to one another. If they are, then we can compute the area and then the volume. Here, to determine the volume of a rectangular solid, we have two bases that are the same size. They're parallel to each other. We will find the area of this base. It's a rectangle, so we'll take length times width and then multiply it by the height, which is actually the distance between those two parallel bases. In a cylinder, we have two bases, a circle at the bottom, a circle at the top, that are parallel and same size. To determine the area of the base, we'll use our formula for determining the area of a circle, which is pi times the diameter squared divided by 4, and then we'll multiply it by the height of the cylinder, which is the distance between those two parallel bases or faces of this three-dimensional object. If we have a prism, we still have parallel faces, we can use the basic volume formula here. We have a triangle for our base. We have an equal parallel base at the top of this prism. To find the area of the base, then, we'll use the formula for the area of a triangle. Base times height of the triangle divided by 2. That will give us the area of the base. And then to find the volume, we'll multiply by the distance between those two bases. And here, to distinguish between the two heights, we'll use a capital H for the height between the two similar bases, and the lowercase h for the height of just the triangular base. Multiplying those two values together will give us the volume of this triangular prism. As an example, if we want to compute the volume of this rectangular solid, looking at it, we have a base of a rectangular shape. We find the area of a rectangle by taking length times width. So 175 times 120, and then the distance between the base and the top base, the bottom base and the top base, is 6 inches. In other words, maybe thickness might be a word that's used as an application, results in a volume of 126,000 cubic inches. The area was inches times inches. We had square inches from the area of the base, and timesing it by the height gave us that third inch dimension, inch times inch times inch, represented by cubic inches. Volume is always cubic units. As an application, if we have a cylinder here, we have a bore is the term used for the diameter of this cylinder. The height is the distance of the stroke. Using the formula, area of the circle, pi diameter squared divided by 4, times by the distance between those two parallel bases, which is a circle in a cylinder, we have our height. So the volume of this stroke for this cylinder, the swept volume, is going to be pi times the diameter or bore length squared times the height, which in car mechanics is referred to as the stroke, and divide by 4 in the formula. In 1969, Ford started to produce an 8-cylinder engine with a 4-inch bore and a 3.5-inch stroke. Bore being our diameter and 3.5 being our height of the cylinder. Let's see if they stated this correctly. They're telling us that this was a 351 cubic inch engine. The volume of one cylinder is found by taking pi times the bore or diameter of the cylinder squared times the height, the stroke length, divided by 4. Simplifying gives us a volume or a displacement of 43.982 cubic inches. That's for just one cylinder. Since this is an 8-cylinder engine, we times that by 8 to give us a total displacement of 351.856, which is above and beyond what the advertisement said. When we have three-dimensional objects that do not have the parallel bases or faces opposite one another, we have to use a different volume formula. And here we have a pyramid, which this is not going to work because there is not another face parallel and same shape as the base here, the square. And so other formulas for three-dimensional objects can be the following. Volume of a pyramid or a cone can be found by taking 1/3 times the area of the base times the height. Here in the cone, our base would be the area of this circle, and our height would be from that bottom, the circle, to the vertex at the top of the cone. To find the volume of this square-based pyramid, we would find the area of the square times it by the height, and in both cases, once we find that, we'll divide by 3. To find the volume of a sphere, we have a special formula where we take 4/3, the fraction 4/3, times it by pi, and multiply that by the radius, the distance from the center of the sphere to a point on the sphere, cubed. That means that measurement multiplied by itself 3 times. If we're looking to find the volume of a pyramid that has the following dimensions, we'll use the formula 1/3 times the area of the base times the height. This pyramid has a square base, a 45 by 45 inch square. The area of a square is side times side. The height of this pyramid is the distance from the base to the vertex, which is 63 inches. Multiplying 63 by the area of the base by 1/3 or dividing by 3 results in a volume of 42,525 inches times inches times inches, cubic inches, for the volume of this square-based pyramid. Problems involving volume can be found in practice set 10 and 11.